Building a world-class speech recognition system typically requires thousands of hours of carefully labeled audio. The researchers behind VietASR achieved industry-level performance for Vietnamese with just 50 hours, proving that the right architecture and training strategy can overcome data scarcity in low-resource languages. Vietnamese speakers face a fundamental asymmetry. While English ASR systems train on tens of thousands of labeled hours, Vietnamese has only a fraction of that available. The authors recognize that 70,000 hours of unlabeled Vietnamese audio existed on platforms like YouTube, untapped and waiting for the right training approach to unlock its value. Their answer lies in a four-stage pipeline that turns abundant unlabeled data into a competitive advantage. The pipeline begins with training a basic ASR model on just 50 hours of labeled data. That model then becomes a teacher, extracting pseudo-labels from unlabeled audio through feature clustering. These labels guide a self-supervised pre-training phase on the full 70,000 hours, and finally, the pre-trained model gets fine-tuned on the original labeled data. The clever part is the dashed box showing component reuse. Each iteration feeds its encoder back into the next cycle, creating a virtuous loop of continuous improvement. The key innovation is what the authors call ASR-biased, self-supervised learning. Instead of learning generic audio representations, they extract labels from a model already trained for speech recognition. This means the unlabeled data gets organized according to categories that matter for transcription, not just any feature clustering scheme. The pre-training phase becomes laser-focused on the actual task. Efficiency matters when you're processing 70,000 hours repeatedly. The zip-former architecture keeps the model lightweight without sacrificing representation power, and masking features directly rather than through complex intermediate steps reduces computational overhead. The entire pre-training completes one epoch in about 12 hours, making iterative refinement practically feasible. The results validate the entire approach. VietASR models consistently beat Whisper Large version 3, a model trained on orders of magnitude more data and with far more parameters. They also surpass commercial offerings from Azure and Google, systems backed by massive infrastructure and proprietary datasets. Each iteration through the four-stage pipeline drives the word error rate lower, proving the refinement loop works in practice. The authors are transparent about scope. They have proven the concept works brilliantly for Vietnamese, but broader validation across multiple low-resource languages is still needed. The pipeline does require some labeled data to start, though 50 hours is dramatically less than traditional approaches. Their commitment to open sourcing resources signals intent to democratize these techniques and enable other researchers to replicate success for languages that have been left behind by mainstream ASR development. VietASR demonstrates that resource scarcity is not an insurmountable barrier. The pipeline shows that thoughtful architecture choices, strategic use of unlabeled data, and iterative refinement can produce systems competitive with those built on vastly larger budgets and datasets. For the hundreds of languages still waiting for reliable speech recognition, this work offers both a proof of concept and a practical roadmap forward. The 50-hour breakthrough proves that smart training beats big data when you align every stage of the pipeline with the task that matters. To explore VietASR in detail and create your own research video, visit emergentmind.com.